Okay, guys, we are talking about or inequalities today. Yesterday, we had talked about ands, okay? So, ands, both parts had to be true. So, we used the example of being a teenager. You had to be greater than or equal to 13, but less than 20 years old. At the same time, you had to do both, right? So, that's an and inequality. Both parts have to be true. For or, it just has to be, it can be true for both, but it only has to be true for one of the two. So, for example, let's say you want to go out to the movies tonight, and your parent or guardian says, sure, you can go out to the movies if you do the dishes or vacuum. Do you have to do both? No. It would be probably pretty awesome if you did both, but you only have to do one, right? You only have to do the dishes or vacuum. That's the deal, right? So, you have a choice. You don't have to do both. Same thing with or inequalities. Only one of the two has to be true. Okay. They're actually a lot easier to solve than ands, in my opinion, because it doesn't really matter. You don't have to worry about if there are numbers that satisfy both, because you only have to satisfy one. So, for example, let's do let's say everyone that's not a teenager. People who are not teenagers.
Which is no. Oh, your son's not a teenager.
Correct. My son is not a teenager. So it would include all the people who are of age, what?
0 to 12.
0 to 12.
And,
20.
Well, hold on. Let's go back to the 0 to 12 part, though.
infinity.
If someone is 12 and a half, they're still not a teenager, though, right? So it's got to
It
be
can only be 13.
less than 13. Exactly. So there's one group of people who are not teenagers, the ones that are less than 13, or Pablo.
More than 20?
Or, now can they be 20?
No.
Yeah.
Yes, 20 and older. So, or people who are 20 years or older.
52.
So there are no numbers that fit both of these at the same time. You can't. You can't give me a number that's less than 13 that's also greater than or equal to 20. It doesn't exist. Right? So if this were an and, it would have no solution. But because it's an or, I've got a solution here, right? And I can graph this. So the graph of these are going to look a little bit different. I still have the 13 and I still have the 20. I'm still going to put an open dot at 13 and a closed dot at 20. But now, exactly, less than 13, they're going to go this way. Greater than or equal to 20 are going to go this way. So ors, very often, the arrows point away from each other. So ands, we kind of just shaded in between. It kind of made a bar. Most of the time, right? Because there are certain exceptions to that. Ors almost always look like this. The two dots and then shade away from each other. You can have a no solution with the and, yes. Can you have a no solution with the or, though? No. No. Yeah. Yes.
Is there like a way that like the 13 can point to the right, the 20 can point to the right as well?
Yes. So not for representing teenagers, but if I just said, hey, give me a number that's greater than 5 or greater than 10. They both point in the same way, but if it can be greater than 5 or greater than 10, why wouldn't I would just say greater than 5, right? Because that fits them both. So that's one of those rare circumstances. So it can happen where they both point in the same direction. You ready for a super confusing question?
Yeah.
Give me a number that's less than 100 or greater than 50.
Learn it, live it, love it.
Anything from
Wait,
what
what
do
do
we
we
do?
do?
Less.
76.
16?
No,
Greater than 50.
I said less than 100 or greater than 50.
80.
Anything from 51?
No, 90.
Every single number that everybody is saying is right.
Yeah.
90.
Because doesn't every number fit one of those two?
Yeah.
So this is super weird. So if I actually had asked you to graph that,
Bless you.
x is, what did I say, less than 100, or x is greater than 50, the graph for this, are you ready? It's literally, I mean, you can put dots, but what's going to happen is you're going to end up shading the whole graph.
That's cool.
Because every number fits one of these two.
That's cauliflower.
So that's one of those rare cases. This doesn't happen too often, but it can happen where they sort of overlap each other. Okay? Majority of the time, like I said, they're going to look just like this, two dots shaded away from each other. Do you remember with the and inequalities how you could have, let me just write an example. So let's write, remember, you could have something like x is, I don't know, greater than 5 and x is less than 10. And then remember we said, okay, well you can rewrite that as one unit. And we started with the smallest number, then x, then 10. Remember that for ands?
Yeah.
So writing it this way, that does not exist for ors. You cannot write ors as one unit. That's only for ands. Okay? So, big star, you cannot write an or answer like that. That's only for ands. Okay, so we will not be putting our answers together as one when we're doing ors. So how do you write the answer to an or? And what do or problems even look like? Well, they literally have to have the word or in them. That's how you know it's an or problem. So you might see something like this. X plus 5 is greater than 8, or, I don't know, how about 2x plus 3 is less than, I'm trying to pick nice numbers. 3, or x is less than negative 13. I don't know. No, it works out fine. It's okay. So, yes, I'm sure. Going with it. So, this might be an example of an or problem. Like I said, the dead giveaway is that it literally has the word or. Ands may or may not have it. So if you looked at your homework sheet from last night, some of them looked kind of like this, right? And it didn't have any words in it at all. And then some of them had it separated with the word and. Okay? Ors always have the word or. All right, so how do you solve them? Super easy, because you're just going to solve each one separately. So in this one, I'm going to minus 5. So I got x is greater than 3. Or, and then over here, what do I do?
Subtract 3.
Minus 3. So I get 2x is less than
16.
ooh, negative 16. And then I
Divide by 2.
divide by 2. X is less than negative 8. Okay, so this with the word or, that's kind of a big deal. You have to have the word or in your answer. Same thing, if it was an and problem, you'd have to have the word and in it or rewrite it as that one unit. You can't just have this and this without an and or an or, because it makes a huge difference. So, if you mean or, make sure you have or in there. Now, how do you graph these? Same way we were doing before. So I need a negative 8, and I need a positive 3. I need what kind of a dot at the negative 8?
Open.
Open, and I shade to the left. At the 3,
Open, shade to the right.
that's it. So in this case, I have my two numbers, open dots, shaded away from each other. Do you still have to flip the symbol if you multiply or divide by a negative?
Yeah.
Of course you do. That's for all inequalities all the time. It doesn't matter if they're ors, ands, if they don't have ors and ands, always. Multiplying or dividing by a negative flips that symbol over. So let's try some like that. Okay. Oh, I forgot I gave you the sheet already. So, someone want to pick one to do together?
Yeah. Oh, wait.
Which one looks hard?
Yeah, you
Number
forgot.
7.
Try 7.
We worked on that
7?
at the end of
All right, 7.
Haley.
So, 7.
the evenings on the front page.
11 minus 2x is less than negative 7, or negative 11.
Is greater than or equal to 89.
Okay. So, or problem, I'm just going to solve each one separately. So I look over here. What would I do first, guys?
Subtract 11.
Correct. Caleb, you paying attention?
Yes, I am. As I'm
Are you paying attention to me?
Yes.
Negative 7 minus 11 gets me? Correct. And then I have to,
Divide by negative 2 and flip the sign.
yes, that sign's got to flip over.
So I was basically doing or for my when I
Yes,
I just carried them by only to both sides.
correct.
So basically I was doing the way
You solve them the exact same way. It just comes down to your final answers. And there has to be a number that works for both things. And if there's not, there's no solution. But ors, it doesn't matter because it only has to work for one. How about this one? First thing I'm going to do is
Add 11.
add 11.
Negative 10x is greater than or equal to
100.
Divide by negative 10.
calm down. It's a math problem.
X is less than or equal to 10, right? No. What? No.
Negative 10. That's it. So now, this is an or problem. So make sure you write the word or. Put a box around your answer or a circle, whatever. And now, let's go ahead and graph it. I need negative 10. I need positive 9. I need what kind of a dot at negative 10? Close. Shaded to the
Left.
to the left, I think, for that one. And then on 9, I need
Open.
open, shaded to the
Right.
right. There we go.
I'm so happy now. It's peace and perfect.
Do you want to do maybe one more that has a fraction in it?
Sure.
No, bro.
Surprised none of the back have fractions, but okay.
Just
Yeah,
do
no,
it.
never mind.
Don't you just do it the same? You
No,
just
no,
carry
mind.
Number 2.
carry it,
No
carry it.
fractions of that.
Number 2 is each fraction.
Yeah. All right, let's do 2.
I mean, or we could do number 6 or 5 or, all of them.
2 is good.
Okay.
All right. So it's an or. I handle them separately. This first thing I need to add 2.
You're cheating.
Some of you are, I don't know, mystified with these fractions. But guys, just think about what you're doing to the variable. Isn't this v divided by 6? Right? Are you with me? I'm dividing this by 6. So I just need to ask myself, well, what's the opposite of dividing by 6?
Times it.
Times by 6.
Bro.
So on this left-hand side, they just cancel. That's the whole point. So you just have v left all by itself. And then 0 times 6 is just 0. Stop thinking that because there's a 0 in your answer or in your problem that you can't do it or it's wrong. 0 is a number like anybody else. You can do 6 times 0. You just get 0. So that's your answer. V is greater than or equal to 4, or V is less than 0. So when I go to graph it, I graph it the exact same way I would anything else. 0 is just a number. I would have an open dot at 0, and I would shade to the left. I'd have a closed dot at 4, and I'd shade to the, that's it. If you wanted to check your answer, give me a number that I could plug back in. According to this graph, what should I be able to plug back in? Is 2 a number that I have shaded over? No. 5. 5 would be a number that would be shaded over, right? Because it'd be over here. So 5 should work. Is 5 going to work in both of them? This and this? Well, let's try it. 5 minus 2 is 3. 3 is greater than or equal to 2, so it does work there. And then if I plug it back in the original here, 5 divided by 6. I don't know what it is, but it's not less than 0. So it doesn't work here. So does that mean 5 is wrong?
No.
No, because it's an OR. It only has to work in one of them. And it did work in this one, so that's a good answer. If I plugged in the number 3, what should happen? What do you think would happen if I plugged in the number 3? Would it work in...
Yes. I'm assuming. Yes.
Well, the number 3 would be right here, right?
Yeah.
If I shaded over the number 3, is there a bar over the 3?
No.
No. That means that 3 should not work in either of my answers.
What about
-1 should work in at least one of them. -1 minus 2 is -3, which is not greater than or equal to 2, so it doesn't work there. But if I did -1 divided by 6, that's -1/6. Isn't that less than 0? It is, so it does work in that one. When you are graphing an inequality, I think some of you forget what the graph even is. The graph is a visual picture of all of the answers that work. So this represents every single number in the whole wide world that works, because we have arrows that keep going on forever. So it's not just these numbers that you see that I've written down. Because the arrow goes on forever, that includes 5, 6, 7, 8, and so on to infinity. Right? Because it's going to keep going. So every single number in the whole wide world greater than 4, you can't possibly write them all, but you can very easily represent them in a picture. That's why we bother with the graph. Does that make sense?
Yes.
Speaking of graphs,
Yay.
why don't we try, I'll give you a graph, you write the inequality that matches that graph.
Yay.
Oh, such fun. Okay, let's try it. So, I'll give you a bunch of numbers too.
Are you serious?
Well, I mean on the number line.
Oh, okay.
So here's some portion of a number line, and then your graph looks like this. We'll start off easy. Ish. So what I would do if I were you, since there's more than one dot, that means it has to be a compound inequality. In other words, it's got to be an or it's got to be an or an and. What'd you say? Which one does this have to be, an or an and? This one's got to be an or. Ands are usually going to be represented like bars. So you know it's an or. So you're basically just going to give me the inequality for that one, and then say, or the inequality for this one. You did it on your quiz. You just have to do 2 of them at once. You know what I mean? Like, you have to do too many ones. You with me, Elizabeth? I've been up since 3:15, so I don't even feel bad. 3:15! Ah. It's gonna be a day. Do you have one for this?
Yeah.
All right, what is it?
X less than 6.
Yes, that is x is less than 6. Then I just write or, and what's this one?
X greater than 8. Or equal.
Greater than or
Yes, that's it. You gotta have the or equal to part because that dot is filled in. Make sense? Okay. What about this one? Give me the compound inequality for that thing. Well, hold on to it for 1 second. Everybody write down what you think it is. It's not on your page. I just made it up. Okay, you ready?
Yeah.
Go ahead, Haley.
0 is greater than or equal to x, and
Whoa, whoa, whoa. You mean like this?
yeah. Oh wait, sorry. X is less than or equal to 0. Okay.
You mean like this? Hold on.
Oh wait, no. I said greater than. It's greater than or equal to 0.
Okay. Well, is this an or an and?
And
It's an and. So what'd you say again? Tell me what you want. X is what?
x is greater than or equal to 0, and x is less than greater.
I will agree with that. You can also write this, since this is an and, you can write it as that one chunk. Does anybody write it as the one chunk? If you're going to write it as the one chunk, you take your smaller number of the two, which in this case is 0. Your arrows always point this way. So I basically have the same things that she has. X is greater than or equal to 0, right? So if I just look at that part and I read it backwards, X is greater than or equal to 0. The Pac-Man's eating the X here and Pac-Man's eating the X here. So I didn't change anything. And then I have the same thing on the other side. This one's kind of easy because it's exactly the same. So there's me putting them together as the one and representation. Okay, one more. Trying to think how I can trick you.
The question is, you can't.
Yes, you're right.
Maybe not with these. You guys are good at these. The only thing I can try and do, I guess I'll do this.
Why? Why?
But does it matter? I mean, it doesn't, it just means instead of writing a 0 and a 3, you write whatever those fractions are. There's not even any computation that you have to do. All right, try this one. Thank you. Oh, okay. Thank you. Pablo, is this an or an and?
It's an or.
It's an or. I agree. What is this one?
X is less than or equal to -10/13.
Okay. And then Haley, what's the other one?
X is greater than or equal to -9/13.
it. Was that so bad? So even though there's crazy fractions in there, it doesn't matter. Because for something like this, you don't have to compute anything. All right, guys. So I think this is a pretty good place to stop.
I like counting.